So now I'm still here to present my colleague Marco Leyton. I don't need any paper to present Marco Leyton because he's my colleague since 20 years. He's one of the first person that I met in the corridor at McGill when I arrived at McGill. So Marco is a professor in our department of psychiatry. He was with Chocky Benkelfat, the first person that started brain imaging studies in psychiatry, in particular in addiction population, in depression, in particular PET, MRI. So.
Thank you, Gabriella. And I think what we're coming down to is cannabis, it's not crack, but it's not lettuce. So here I am, the last speaker. Compared to everyone else who's spoken today, this is really a new field for me. I have the least experience with cannabis research, and perhaps because of that, I'm not actually going to be presenting any of my own data. That said, I did feel that for an event like this, it would be worthwhile to present an emerging field with a really quite exciting possibility that the endocannabinoid system might be a suitable target for treating addictions. All right, I have no conflicts to report. The primary learning objectives, first of all, just to get a sense of what the available cannabinoid medications are, and some of our previous speakers have already alluded to that already. To give you a sense of just the rationale. Why in the world would anyone think targeting the cannabinoid system would actually be helpful for addictions when it's an addiction itself? And then finally, what is the actual empirical evidence that targeting this system is genuinely helpful? All right, just to get a good sense of what this is referring to, these features of the cannabinoid system have been alluded to already by our previous speakers. There are three main features. There are two cannabinoid receptors. The CB1 receptor is the primary receptor within the brain. The CB2 receptor is also evident within the brain, but at really quite low levels, and serves more as a primary cannabinoid receptor in the periphery. There are two main endogenous cannabinoid ligands, anandamide, which is a partial cannabinoid agonist, and 2-AG, which is a full agonist. There are also two metabolizing enzymes for cannabinoids, Tha, which inactivates anandamide, and McGill, which inactivates 2-AG. I prepared this slide just in case other people didn't go over some of the various different compounds that have been developed for targeting the cannabinoid system, and I won't belabor it since people have mentioned this already a number of times. I'd just like to mention these two last ones to give greater emphasis to them because they differ from the others, which have mainly been developed as agonists for the CB1 receptor. Rimonabant was the first and, to my knowledge, the only it's cannabinoid antagonist, inverse agonist that's been developed for humans. Initially developed and approved for the treatment of obesity. It actually seemed to work. The results were really quite promising, but then quite horribly severe psychiatric side effects were found in a number of participants, and we're not likely to see this compound again. But the results are so interesting that I think it encourages us to continue to look for other ways of targeting this system that might not have these same psychiatric side effects. Certainly one possibility for that is CBD itself. A version of this has already been prepared, and this was mentioned in an earlier talk. It's been approved for the use in a quite severe form of juvenile onset epilepsy, but it might turn out to be helpful with various other psychiatric problems as well. All right, so why would we even begin to think that the endocannabinoid system would be a reasonable target for the treatment of addictions? And the rationale for this comes from a number of converging lines of evidence, not least of which is this interesting study indicating that within the United States, and similar results have been seen elsewhere, but well documented that within the United States, in the years following the implementation of medical cannabis regulations, there was a decrease in opiate-related mortality. This was very much unexpected, but the findings have been consistent, and during the years following implementation, if anything, the effects became larger rather than smaller. These effects are robust to the specific site or year of implementation of these laws. They're not driven or related to people who had intentionally overdosed as a suicide attempt, and nor are they related to whether or not people were uniquely using heroin as opposed to prescription opiates. The mechanism by which this effect is occurring is unclear, but it's only one possibility that's been suggested by a number of writers, is that there might be some sort of substitution effect going on, and so that if you're using both opiates and cannabinoids, maybe for pain, you might actually end up using lower doses of opiates, and as a consequence be at lower risk for mortality. The mechanism by which this might occur pharmacologically, I think there's a very plausible explanation of how this could occur. Cannabinoids can actually induce the release of endogenous opioids in the brain, and that includes the release of beta endorphin within the dopamine cell body region, in the ventral tegmental area, as well as its target site, the nucleus accumbens. Cannabinoids can also increase dopamine cell firing, and this has been seen in response to THC, as well as the endogenous cannabinoid, anandamide. And the mechanism by which it accomplishes this is really quite interesting. It's different from how most compounds work within the brain. So cannabinoids increase dopamine cell firing, but they're not actually acting on the dopamine cell directly itself. There are no cannabinoid receptors on the dopamine cell. Rather, the engagement of the dopamine cell via activation through other transmitter systems induces the dopamine cell to synthesize the endogenous endocannabinoid, in this case 2-AG. 2-AG is then released where it activates the presynaptic inputs to the dopamine cell and then modulates and primarily inhibits both glutamatergic and GABAergic input to the dopamine cell. We can imagine that individual differences in the balance in these two effects might well be related to individual differences in the dopamine response to ingesting a cannabinoid substance. As Gabriella mentioned, there's also evidence that cannabinoids can engage the serotonin system, and depending on dose and other features of the regimen, we can see both increases in serotonin cell firing as well as decreases. The self-administration of addictive drugs can also engage the cannabinoid system. And so here in laboratory animals, self-administration of heroin increases anandamide levels within the nucleus accumbens. Ethanol self-administration increases 2-AG levels within the nucleus accumbens. This effect, though, is not seen across all addictive drugs, and cocaine was not seen to have any effect at all. There's also, I think, and most intriguing for the current topic, evidence that blocking these effects, using again this CB1 antagonist, actually prevents, decreases heroin self-administration in rats. Whoops, boy, how did I get all the way over there? Boom, boom, boom. Decreases ethanol self-administration, and as you might have guessed based on the previous slide that I meant to show, had no effect on cocaine self-administration. All right, so what about in humans? What is the evidence actually in humans that cannabinoids can affect addiction-related behaviors? Well, the first, actually, then the largest literature on this, and then when you think about it, perhaps not surprising, is that people have looked at whether cannabinoids, synthetic THC and other compounds might actually diminish cannabis withdrawal in people who are quitting heavy cannabis use. The effects are not massive, but it's been a quite consistent finding in the literature, both in clinical trials and laboratory studies, that indeed synthetic THC, not surprisingly, decreases cannabis withdrawal. If nothing else, this is a good proof of concept type of study, and may even find a role within the clinic. There is an unpleasant, not life-threatening, but unpleasant withdrawal syndrome that can develop in very heavy cannabis users. More disappointingly, though, these studies found that these synthetic THC compounds had no effect on abstinence rates. So it helped people endure the withdrawal syndrome, but it didn't decrease the likelihood that they would stop using cannabis subsequently. I think a bit more intriguingly, and there's only one study to date that I know of, a synthetic cannabinoid, dronabinol, has been tested to see whether it might also diminish opioid-related opiate withdrawal syndromes. And again, the potential mechanism might be related to the ability of cannabinoids to induce endogenous opioid release. Pleasingly, and as they predicted, and as the primary hypothesis had been in this study a priori, sure enough, the administration of this synthetic THC decreased withdrawal symptoms in opiate-dependent addicted individuals. As a secondary measure, and they did not really predict this a priori, but following the 1 week-long dronabinol trial, all patients were then moved to an naltrexone treatment regimen and then followed up for their ability to stay in treatment and sustain abstinence. Somewhat to their surprise, but I think really quite an intriguing finding, is that those individuals who smoked marijuana at home were much greater at treatment retention. And that was irrespective of whether they'd received the dronabinol during the 1 week trial. Those individuals who were smoking marijuana at home in either of those treatment arms did much better during the subsequent weeks. There's also the small literature on whether using the converse approach, actually inhibiting the cannabinoid system using this rimonabant and CB1 antagonist, inverse agonist, whether it might affect tobacco smoking. There are only 2 clinical trials that I know of. They were both found positive results. A very encouraging result. As I said, we're not likely to see this going to market, though, because of the unfortunate side effects. But it does, I think, encourages us to view this as a viable target that we can maybe tap into in other ways, whether it's with CBD, which doesn't seem to have any of these sort of side effects, or some new compound yet to be developed, or alternatively targeting the cannabinoid system in other ways, such as through the enzymes. The same approach has been tried in alcohol use disorders, very limited work, one clinical trial, 1 laboratory study, but here the effects, there is no evidence in either of these 2 studies. Still, it might be premature to give up completely, again, based partially in the animal research, partially in the success seen in tobacco, partially in the fact that this is I would hardly consider this a thorough or exhaustive testing of the hypothesis. So in summary, this small literature. I'm at the end already. We have evidence that synthetic THC and perhaps other THC compounds decrease both opiate and cannabis withdrawal, but the evidence that they actually improve abstinence rates is still quite preliminary. Rimonabant showed really quite encouraging evidence for facilitating tobacco abstinence, but as I keep saying, we're not likely to see that compound per se being used, but it does open the door for tapping into the system in other ways, either with CBD, yet to be invented, discovered CB1 antagonists, or treatments that tap into other aspects of the endocannabinoid system. So overall, I think these very preliminary findings is a quite new field, are exciting, encouraging, and really suggest that this is worth pursuing for future research. And that really brings me to the end of the presentation. Thank you. We have time for a few questions. Yeah. Oh, yes, yeah. Lily, hi.
I wanted to thank you all for a very stimulating event. No, but there have been papers that have shown that the effects of cannabis on sperm and ova have a long-term impact on the reproductive capacity of people and on infant effects or fetal effects in utero. So the question is, I know this was kind of centered on the brain, but if we're talking about cannabis, that is a very significant effect. There haven't been many studies on it, but there certainly have been some. And I think that in the discussion of the pros and cons and the possible dangers of cannabis, that aspect really needs to be addressed as well.
I think that's an excellent point. I certainly can't add anything to that. I open that up to our other speakers if they want to add. Yeah. Yeah. No, I think that was a really terrific point. So maybe we'll invite Dr. Turecki back up to the podium, and he's going to say a few closing words. Thank you.